I just went ahead and hit record. Jared, you want to say an opening prayer?
Sure. Are we waiting for anyone else, or are we just getting started?
Let's just go ahead and start it, because I think it's already. We should probably stick to the start time.
With that, yeah. Okay. Heavenly Father, we're grateful for this opportunity we have to meet tonight, and ask that we might be able to study effectively and work effectively as a group, and for the opportunity we have to stay online, and for our many blessings and these things we say.
Amen. Amen. All right. So I guess I'll share my screen and we can begin like we do all each week. Oh man, I was working on something else. So, did anyone else have trouble with part 2?
No, it took me a minute, but once I kind of watched all the tutorial videos and stuff, I got it.
So, I took a bunch of notes in a spreadsheet, and as soon as I got to part 2, I got thrown off, because this first question here, the way it's worded, maybe doesn't make sense to me, but I was hoping we could just go over a couple of these first so I could grasp what I'm missing. But so here it's talking about the GMAT scores, and it says a BYUI professor would like to estimate the population mean from a simple random sample of 50 people's scores. The sample mean of these 50 students is 541, assuming a population standard deviation of 32. Answer the following questions. And so, let me pull it up here. So here's all my numbers, right? And I was trying to answer these questions with it, but I didn't read anywhere what is the point. I don't even know what point estimate means, to be honest, because it's not worded like that in the reading.
It was in the one of the tutorial videos. It said that the point estimate was the sample mean.
So that's
I think it was the first
sample mean, the 50.
No, the 542 or 541.
Yeah.
Oh, okay. So that's just asking me for what the number of. Yeah. Okay. That's what I thought, and I just didn't want to do it wrong. So I put the mean is 541, right? The number's 50. Deviation is 32. Is that right?
Yeah, standard deviation is 32, and the point estimate or the mean is 541.
Okay. I must have missed that video then, because I was looking all over for it and it just didn't make sense to me.
It also says it in the text.
It does? Because I was reading all over. I didn't see it again.
I'm pretty certain I saw it from the text, and that's how I got my answer.
Okay. I must have just kept going over and over and couldn't find it. So are you guys all right if we go through these real quick before we do the test?
If you want.
Yeah.
To be honest, I'm fine on all these, and on all the homework stuff, where it was saying to do it at 90% confidence with the margin error of this or that, I was just fine with that. But then when I started reading the different terminologies, because they word it differently than in these, it started throwing me off.
Yeah, I haven't looked at the homework yet, so.
Yeah, neither have I.
It's not the homework, it's the, what was it called? The self, you know,
The purpose
the
assignment.
self-learning or whatever it's called. The here, it's right here. You know, the self-learning with the lesson. I don't know what you call it.
There's the individual preparation,
That's it.
and I did that, but I don't see your Excel sheet. I don't know where you got that from.
This is all from the reading.
Oh, you just copied the reading?
Yeah, the practice problems and stuff. You know what I mean?
Oh, I didn't even look at the practice problems on it. Maybe that's why.
Well, they're worded differently than in part 2, and that's why I'm getting thrown off. Because I did it just fine in there, and when I got to this, I'm like, why is this different? But anyway, I'll try to go through it real quick because I have the gist of it. I just wanted to make sure I'm doing it right and understand what they're asking for. But
Well, I was having a problem with 8 and 9, and I did it, and I got completely different answers than the answer key, and I walked away from it for a while and came back, sat down, and it just clicked how they got it.
so what did you do for creating a 95% confident interval?
Here, I'll paste my formula into the chat.
Okay.
So what I did was I had the applet open, and I plugged the 95% into the area, which it talks about later on in the text.
Yeah, and it even gives you for like the 3 that they use, 90, 95, and 90.
Yeah, they do give you the 3. And I was confused about that, and that was my problem for a while before I finally figured out what they were doing, because I was going off the formula where it had the 2 in there, so I was calculating it with the 2 instead of the 95%.
6 or whatever. Yeah, I understand that. I understand that just fine. But this says create a 95% confidence interval for the population mean.
Yeah, so it's the same thing. You just find it.
Yeah, so basically all you're doing is you're just calculating it out. So you're putting the sample mean, which is, or the point estimate, whatever you want to call it, the 541, and you're subtracting it by the z-score for 95%, and then you're doing you're multiplying that by the standard deviation divided by sample size that's been square rooted.
This is my example right here, right? So I take this minus that, right?
Did you look at in the chat, or can you not see that right now?
Well, I looked and it didn't show anything in the chat.
It's right there on the right. You see it says AJ Walker in green?
Gotcha.
Yeah, so that's the formula I used right there. So it's the 5, basically the point estimate minus the z-score for the percentile, and then it's standard deviation divided by square root of sample size.
Yeah.
And then you're doing one adding it and one subtracting it.
Okay.
And then you just calculate it out. Here, I'll post up the rest of what I did to show for it. So then I did the in parentheses. So I square rooted the 50 divided by the 32 and got an answer. Then I multiplied that by the 1.96. And then I have one equation I'm subtracting it, and one equation I'm adding it. And then that's your margin of error is the 531.95 or 550.05.
So which step did I miss here because I did my mean, the 541 minus the z-score for 95%, divided by the square root of the number of the population. Is that right?
I can't see this.
Yeah, it's too small for me to make out what you did there,
Oh, really?
Hold on.
and
Go
I have a
back.
hard time with
I mean,
hearing it and understanding it. Oh, yeah, there we go.
So what I did was I took the mean, 541, minus 1.96 z-score.
Okay, I think I see what you did wrong. You put the parentheses in there.
Don't do that?
And okay, so then it's the 541 minus the m, which should be the 1.96,
You're also
and
missing.
then you forgot the standard deviation.
Oh my gosh, that's what I
Yeah,
did
you're
wrong.
missing the standard deviation right before the square root.
So it should
Times the deviation, right?
yeah. So it's times and then the square root. They're divided by the square root.
And then, do I need this in parentheses here?
I would put the standard deviation divided by square root into parentheses, so it knows to do that whole part first.
Yeah, I think that's right.
Like that. Let's see. 532.13.
Close.
That gets you really close. I don't know. I don't use Excel that often, so
Well, times is supposed to go first. So I'm pretty sure that this is supposed to be like that.
No, I mean,
no, because you need the square root divided by
you need to
the
change.
other one and then multiplying it by the other.
I think you could do that. Put the parentheses, yeah, right there.
Like that.
Yeah, what does that give you?
532.13.
How about go back into it? Put a parentheses in between the M174.
Like that.
End of it.
And at the end of it.
Oh, I see what you're doing.
174.
At the end to make it separate, so it doesn't get
Yeah.
separate the equation. Use
And then see if that will give you the right answer.
Like that.
Still pulling up as 532.
Are all my numbers right here? Because I got the 5. Yeah, that's right.
541,
32.
1.96, 32, and 50. Yeah, those all seem to be the right numbers. The only thing I can think of is it's rounding it instead of going to 3 decimal places, because I actually have it to 3 decimal places.
Oh, maybe. Let's try
And
it
maybe
again.
that's that other one rounding it up to. It could be rounding up to 0.52.
Hold on a minute. So I got x
And-
minus z.
You accidentally
Fine.
added in a extra blank square.
Oh.
And then you deleted out the.
There we go.
Yeah, there we go. That's right.
If that was it. No. What in your answer? What now?
6 times.
You ready? In a separate cell. John, go to a separate cell in your Excel.
Yeah, I think
Yeah.
that's what it is. Is it's not rounding out to the third decimal place, and it's
Well,
rounding up. Because I just did it by my calculator and got really close to what they're putting it.
So I'm doing something wrong with Excel then, right?
Just in that Excel, that cell right there, put equals to parentheses standard deviation divided by this. Hold on. Divided by the square root of 50, or n J169.
Okay.
Then move the decimal point to just 3.
Well, that shouldn't matter.
Will that not change anything? Because that's the thing, is like this is just getting more exact when when I did it, I got the same as AJ, but I just cut off the decimals like that. But I did it in a calculator and not in Excel, so I guess Excel is a little more accurate.
Yeah, I think Excel's just rounding somewhere and it's changing the answer.
Well, we rounded for the 4.525 down when we did it, but his is like, watch, click on it again, and if he puts out the number, it's like almost half. It's like 0.4 or something right afterwards. See, yeah, and that's why we cut off a big chunk of it. So that's all it is. I wonder if it'll give us leeway on that, like on the quiz.
Well,
It has to be super precise.
wait, go farther out on the 4.525.
So I just got to times that 532.13. I got the same answer. Something's not right here.
That's going to completely change your answer then.
I'm pretty sure it's honestly just because Excel uses like further decimal points.
Oh, wait a minute. No. All right. So that times standard deviation. Oh, wait, no. We already did that. The standard deviation divided by, so times that. What's going on?
I think it's that parentheses you have with subtracting out first and then multiplying.
Yeah, that's it.
Because
Okay.
that gets you really close to what we have.
Okay.
And I just don't know why it keeps.
So that's what anyway, I think this is right.
Yeah, that's right.
Okay.
Actually, that one's wrong according to the answer sheet.
Number 8.
I don't know what I'm doing wrong.
Yeah, it should be 531.95 or 550.05.
The other one is when I do it like this, so I would go this plus the z-score times this. 549.87.
I see it's still off.
No, it should be 550.05.
Wait, guys, are we on number 8 here? Because I have answers. That's what I came up with.
Well, if you look at the answer sheet, it will give you the right answer.
Answer sheet for number 8.
Well, I know it gives you the right answer, but I still didn't understand how it got there.
Did I just forget to switch that on my end? I think that's maybe it.
John, hey, John, I use Excel too for all this stuff. And for me, this formula was like too long in Excel. So like I broke, but I broke mine out. like I said, that formula for me was just too long. So this is what I did in Excel. Down more. I don't know if you can see my screen, but like I broke it down more so that it was like simpler for me to like visualize and see and understand what the formula was doing.
Okay, now I figured out why I'm showing a different answer.
So your answer is the same as mine.
Yeah.
Okay, so I fixed my equation, but I forgot to re-answer it and put the correct answer at the bottom. So I was looking at a completely different answer than what was the correct answer.
Okay.
So that's
All
a problem on my end.
Okay. Hey, would you share your spreadsheet with me so I can compare to see if I like your design better?
Yeah, I'm sharing it right now. Can you see it?
No, I mean like of your equations. I want to make sure that my math is right in the order of operations, basically, because I got a little confused just talking over this one.
He wants you to click on so you can see what you inputted for the cell.
Oh, yeah. So like basically, like as you can see, like I broke mine down into two parts. So basically, like I didn't have that whole drawn out formula programmed into one cell because for me it was too busy. There was too much going on there. So first I did like the margin of error, as you can see in yellow. I had those calculated, and then the confidence interval I just have in a separate step. And then up here, this number here is basically the margin of error calculated out separately. As you can see, it's just the standard deviation. Oh, I guess it's not even the whole formula. Yeah, it's not even the whole formula for the margin of error. So I pretty much have it in 3 steps here.
Okay, I see what you did. Yeah, it's the same. I did it right then. I just have mine
You
all
had it
in.
right.
Yeah,
You
you
had
got
it
the
right.
right answer. When I was comparing your answer versus my answer, I forgot to rework the equation and put the right answer. So I thought my answers were the right answers and they were wrong.
Gotcha. Okay, so that makes sense then. This is the low. This is the high. All right. And then for number 9, say the sample size changes to 100, and then I would just change my sample size to 100, and it'll give me my new numbers. Well, it should.
Yeah.
There we go. Okay. All right, now I got the equation working for me. All right. How does the margin of error for the 95% confidential interval sample size compare?
So you're looking at 10 now. Okay.
Raises it. Okay. All right.
You're just comparing the difference between 8 and 9.
Yeah. Then a 90% with 50 students. I've already done all this for other ones, so I can do that one myself later. But how does
So then 11, you're just changing the 95 to 90%,
Mm-hmm.
which is just a different z-score.
Yeah. So how does the margin of error for the 95% confidence interval that you computed in question 8 compare to the margin of error in 90% interval that you did in 11? So the 95% is larger.
So this, you're just comparing 8 and 11. And how I worded it was, as the confidence interval gets smaller, the margin of error gets smaller.
Mm-hmm. All right. Number 13. BYU professor would like to repeat the experiment, but he wants to make sure he has enough students in his sample to ensure that the margin of error is 5. So I had a really nice, where's it at? No, I think that was it right here. Yeah. I had this nice little equation going, so I can just punch those numbers in myself later as well.
Just here, I'm going to add this to the chat. So that was the formula that I used on it. Here's the rest of my equation going outwards. So simplifying it down, just in case if anyone needs that.
Okay. I messed it up. There it is. Know what you guys got for 13? 158?
Yes.
Okay, just want to make sure I was doing it right. All right, thank you. Anyone else have questions about part 2?
Nope.
Okay, cool. Ready for the group test or group quiz?
Yeah, let's do it.
Okay. Thank you guys. I really needed that help. I know it seemed like I knew what I was doing, but after the fact, but my brain just couldn't wrap my head around that second set of questions because I got thrown off by that first question.
Yeah, I mean, I did 8 and 9 and got completely different answers. And I was frustrated and spent like 20, 30 minutes trying to figure out how I did it differently than them. And I walked away for like an hour and I came back and looked at it again, and it just clicked as to how they did it.
All right, so number 3, find a margin of error for a 90% confidence interval when the standard deviation is 50 and the number is 25. Round to 3 decimals. So we got 90%. We got a deviation of 50 and a number of 25. Wait, I'm on the wrong one here.
You have to say they said yes or they said no. So it's your responsibility to come back and say, yes.
Oops, let's put this back.
16.45.
You need to ask.
Oh yeah, I got
my responsibility.
I got 16.45.
cool.
Is that what everyone else got?
That's what I got. That's what Tim got.
16.45. All right. Had to find my right equation there. Down to 3 decimals. Is that 3? Which of the following statements is
I think number 4 is B. I think.
Yeah, that's what I put. X bar is a point estimate of.
Yeah, that's what I got. Is B as well.
correct?
So that'd make number 526, right?
I think it's 526.
Well, if it's off the example question.
Yeah, it's 526.
What is the original air confident interval for UMass score?
7.69.
So it's
Do you know what we have to round it to for this one?
Third.
3 decimals?
3 decimals?
Yes.
27.685. Is that what you got?
Twenty-seven point 685. Yeah.
27.685 is what I got as well.
All right. Number 7. What is the lower limit of the confidence interval? Round to 3 decimal places.
What was number 6?
27.685.
Thank you.
So 7 should just be taking 5 and subtracting out 6.
So we got
I got, for number 7, I got 498.315.
Can you repeat that real quick?
498.315.
That's what I got as well. And 8 is just adding 5 and 6.
498.315.
0.315.
All right, me too. The upper limit 550. Wait, I didn't make sure that's right.
Yeah, 553.685.
I got 553.685.
Yeah, that's what I got.
What would happen to the rule of
I
confidence
got the same.
if Gina increased the sample size? Let's see. If I go up to 100,
It will decrease.
That should decrease, right?
Yeah. That's what I'm thinking.
Yes, will decrease.
the number gets
Number 10, it will increase.
number 9
Number 9 will decrease.
Yeah, number 9's decrease.
decrease. Can you guys explain that to me? So
Yes, if you increase the sample size, you are dividing for a higher number, so it will decrease the result.
oh yeah. I guess I'm just trying to understand why these numbers increase.
It's fine.
Well, that's what it's. That's
Okay, so I think how it would increase is because you're switching to a 0.99% confidential interval, which would give you a higher Z score.
Right?
And so if you're multiplying by a bigger number, it's going to increase.
The accuracy then. Oh, is that kind of what it's like?
Well, because if you're, let's see what.
I'm just trying to better understand it as well.
I'm trying to
Yeah.
think of how to word it properly.
If you place 99.99 on the applet, you will have a higher C score, which is 2.576.
Mm-hmm.
Then multiplying by a higher number will give you a higher result. That's for number
Yeah.
10.
Yeah, so as you're multiplying by a higher number, you're going to end up with a bigger number that you're taking out from the sample mean, or whatever word they're using for that. So your distance between them is going to become bigger.
So here's what I'm trying to understand. So watch. This is what I mean. Watch. So if I take number minus this, right? Let's just say. So I got. No, that's not a good example. This minus.
Just increase the sample size and
Now
see
what?
what happens.
Increase it. Oh. Okay. The
Because
number.
they're not talking about increasing the sample size, they're talking about increasing the Z-score.
The confidence interval is what they're talking about.
Yeah. So if you look at your little box
It
that
went
says
smaller.
90%, 96, and 99%, so instead of using the 1.96, you're using the 2.576.
Still on number 9, guys. I'm not talking about number 2.
Oh,
Yeah, I just wanted to understand why it decreased, but I just figured it out. Yeah, I don't know who started number 10, but I was talking about number 9 still.
I didn't realize you were still on number 9.
Yeah, I was trying to understand the numbers if they were increasing or decreasing with the larger size.
I explained it the best, just that you're now dividing from a higher number.
Yeah,
Yeah, that makes sense.
because you're square rooting it, and so as the number gets bigger, even if you square root it, your number's still going to be bigger. So you're dividing out. So you're going to end up with a smaller number subtracting out from your sample mean.
Yeah, so this helped me do it when I saw I know that when I have a bigger sample that it'll become more accurate for all this math. But confidence interval width, I just wanted to understand what it did. That helps me visually understand it now. All these terminologies are really hard for me to grasp, guys, so bear with me.
No problem.
Oh, wait, I'm on 10 now. All right, so what would happen to the width of the confidence interval? Gina changed it to a 99%
It'd be
confidence
an increase.
increase.
Because you're changing that z-score to a bigger number.
Mm-hmm.
So the distance between your high point and your low point is going to be bigger because you're subtracting and adding a larger number.
Okay, that makes sense. All right, someone want to read 11?
Yeah, I can read it. It says, Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need?
Oh, here we go.
So this is going to be like working backwards to find the answer.
This is the same as 13 on the
On the
individual
practice.
preparation.
95% confidence in a sample size of 400.
Yeah. No,
5.8.
we need to find the sample size. The standard deviation is 400.
I'm sorry, that's what I meant.
Yeah.
245.862.
Just round up to the nearest whole number.
Oh, yeah.
So it'd be 246.
Yeah.
Yeah, that's right. There we go.
So I got an answer of 246.
Yep, me too. I'm so glad I'm meeting tonight. I really needed that clarity. I was freaking out earlier. All right, someone want to do 12?
I can read it again if you want.
Sure.
It says the mean salary of actuaries is $100,000 and the standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. Set up a hypothesis test with a level of significance at 0.05 and blah, blah, blah. You collect a simple random sample of 36 women salaries and find that X bar is $111,000. Use this information for the next 3 questions. Question 12, what is the lower limit of this 95% confidence interval?
95%. So number 36. 100,000.
The mean is 100,000. Or what do you need?
Deviation 36,730.
Yeah.
Okay, I got my my lower limit down to the nearest whole number. So $88,002.
Mm.
So I got 99,002.
What if you change U to 111,000?
Yeah, maybe that's what we need to do. Because we're talking about the sample.
Yeah.
Yeah, you're right. $99.
Because I realized that
Yeah,
it was,
'cause you need
that's what
to-
they thought it was from the sample. It sounded-
111,000 because that's the sample mean.
Yeah, that was my fault.
So the other one's the population mean.
Missed it.
Darn it. Okay.
All right. What is the upper limit of 95% confidence interval? I got 122,999.
One more.
Can you add another decimal onto yours, John?
Sure.
Yeah, so it's going to be, we're going to round it down, I think, aren't we?
Oh,
Yeah, I got 122,998.
Yeah, because that's what I thought it was, but
yeah, you're right. I had my my screen, my bars are too thin and automatically rounded it lower.
I always have to oh, it's so small. And is 14 all of the above?
That's what I put.
Requirements.
All of the above should be right.
Yeah.
So I'm going to submit.
Get any wrong?
199 for 13 or 998?
I got 100%.
998. 122. 998. All right, good job, guys.
We meet on Thursday?
Yeah, Thursday at 9?
Yep,
I think this 9 o'clock works much better.
Yeah, I agree.
it works for me, except for when my other class has to go late. So this should be all right. It's just kind of late for me. It's like 11. All right, guys. Well, I'll post the video. Thanks so much. It really helped me tonight. So guys, so thank you so much.
Thanks, John.
No problem.
No problem.
I'll see you guys.
All right, see you guys Thursday.
See ya.
Yep.